All right, we now have 3 soil samples from 3 different sites that were collected using your rovers. Your rockets brought them down to Earth, and now it is time to do some testing. We are looking to build a habitat at one of these 3 testing sites. Your mission right now is to perform tests on these soil samples in order to help us best determine which site we should choose to build our habitat at. You are going to need to test these soils for nutrients that might be found in the soils, for pH, for moisture levels, and we've even collected some rock samples from the different sites, and we'll need to test the hardness of those rocks as well. To help you along with your tests, we've given you a packet. This packet will not only have some background information and questions for you to answer while you're waiting for your tests to be completed, but also areas for you to write down the results of your testing as well. Once you have completed all the questions in this packet and have ran all the various tests, you are going to select which site you believe we should build our habitat at. Let me go over how to run the various tests. Before I explain the tests, let me go over some vocabulary that you may come across in your testing packet. You may see something referred to as a soil sample. That is referring to the container that has only dirt in it. It will be labeled A, B, or C to correspond with the 3 sites. Rock sample means a container full of rocks, either labeled A, B, or C, like this. Now, for your testing, you may come across something referred to as a solution sample or a solution of soil sample, solution of sample. If it says solution, it's referring to the container containing a clear liquid that might have some discoloration of it, also labeled with an A, B, or C. This is the solution. Some of the tests may refer to something as a comparator. This is the comparator. It has a test chamber, which is the smaller chamber, and a reference chamber, which is a larger one. The blue is for phosphorus. The orange is for potassium. The purple is for nitrogen. And the green is for pH. You may also come across a reference to a bag of test powder. Those are small little plastic bags that are labeled with the name of the test and have a powder inside of them. To check for the moisture level, you're going to need 2 main things: the soil sample and the probe to check the moisture level. This test is fairly simple. You're simply going to take the metal piece of the probe, stick it into the soil, try to go as deep as you can, and then you're going to read the moisture level. It goes from dry to moist to wet. Once you have your moisture level reading, take the probe out of the soil sample and then using a dry cloth or paper towel, remove any of the soil. This is now ready to be used to test the moisture level of the different site samples. Please make sure you do not stick this metal end directly into water, as that will ruin the probe. pH. To test the pH, you're going to need the green comparator, a bag labeled pH with the powder inside, some water, a pipette, and a bit of the soil sample from whichever site you are doing the test on. You're going to start by taking the cap off of the comparator. Please make sure that this little film stays in place. That is actually going to be how you figure out what the pH is. You are going to fill the test chamber, which again is the smaller of the two chambers, to the soil fill line, which is this lower one right here, with soil from your site. Do the best that you can. It doesn't have to be exact. Okay. Once you have it filled with soil, the next thing you're going to do is add the contents of the bag of pH testing powder into the test chamber. You're going to want to try to get as much of the powder into the test chamber as possible to run as accurate a test as you can. Okay. And then you're going to fill to the other fill line with water. Okay. Place the cap back on tightly. And then you are going to shake it thoroughly. Let it settle for about a minute. And then after a minute, you are going to compare the color of the water to this color chart right here. It is best if you can hold this up to a window, but the lights of your classroom will work just fine. Again, the idea is to best match the color of the solution to the color provided here to figure out what the pH of that soil sample is. Once you have that pH written down, you are going to empty out the comparator, clean it out as best you can with water, and then use it for the next soil sample from the next site. When you're running the pH test, make sure you test the pH of all 3 sites before you put the pH tester comparator back. Testing for the nitrogen, phosphorus, and potassium actually all have the same steps to them. The only difference is the comparator and the powder that you use. So I am going to show you how to perform all 3 tests using just nitrogen for right now. First, what you need to do is you need to have the correct comparator for the test you are going to be running, the correct bag of powder for the test that you are going to be running, and you're going to need the correct solution for whichever site you are going to be doing. So this is for site A. What you're going to do is take the top off of your comparator, head over to the solution of the site you are going to be testing, and with your pipette, you are actually going to fill both the test chamber, the smaller one, and this larger chamber as the reference chamber to this fill line right here with solution. This is to account for any discoloration that the solution may have right off the bat. Once you have it filled, you can take this back to your station and continue to work on it yourself. So you are going to need to empty the entire contents of the nitrogen bag into the test chamber of your comparator. Again, when doing so, be careful to make sure that the powder only ends up in the test chamber. You do not want powder to end up in the reference chamber. And you're going to do your best to get as much of the powder into the test chamber as possible. After you're done, put the lid back onto the comparator, seal it tightly, and you are going to shake thoroughly. I prefer to shake it for an entire minute, just to make sure that the contents are really mixed up. All right. Afterwards, you're actually going to want to set your comparator down, and you're going to wait 10 minutes to allow the color to develop. Please make sure you are paying attention to the time. You do not want to go over 10 minutes. During this time, while you are waiting, you can always go to your packet and answer some of the questions that are found within the packets, or you can move on to do some rock testing while you are waiting for the color to develop. After the 10 minutes is up, you are going to take the comparator and you are going to do your best to compare the color in the test chamber with the color over here on this side of the chart. Again, this is best done if you can get some sunlight on it from a window. However, the lights of your room will suffice as well. And as you compare the color best you can, it'll tell you whether it is depleted, deficient, adequate, sufficient, or if the nutrient you are testing for is in surplus. Write down your answer in your site record for the correct site you are working on. Once you have your answer for the nitrogen for that site, you are going to dump this out and clean the whole comparator out with water, and then you can get started for testing the next sites as well. As a reminder, even though I demonstrated with the nitrogen, this is how you would perform the phosphorus and potassium tests as well. All right, for the rock test, you are going to take the samples of rocks and you are going to do two different tests. One is a streak test. So you're going to use the white and black streak plates for that. And the other is a hardness test. You are going to need a glass plate, a nail. I have a copper penny, but you might use a penny or a copper plate, and your fingernail. First thing you're going to do is you're going to run the rock along the streak plate, and basically you are testing to see if it leaves a streak of color on the streak plate. So you can see this rock did not leave any streak of color on the white. It did leave a faint mark on the black. All right, that's the streak plates, fairly simple. Next, you need to test the hardness of the rocks, and you have to test these in order. So, the first thing you're actually going to do is take the rock and your fingernail, and you're going to see if you can leave a visible mark, a visible scratch mark, I should say, in the rock. Okay. If, using just your fingernail, you can leave a visible scratch mark inside in the rock, then you are done testing that rock, and you are going to add this towards your count of rocks that can be scratched by a fingernail. If your fingernail cannot leave a scratch in it, you're going to move on to either the copper plate or the copper penny, and you're going to do the same thing. You're going to try to leave a scratch mark with that. If it does leave a scratch mark, that's great. You're done testing with that rock. You can count it towards number of rocks that can be scratched with copper. If it does not leave a mark, you have to move on to the next item, which is glass. This is a glass plate. Please do not press very hard. You do not need to press hard with any of these materials to test the hardness. Just lightly run the edge over the rock. Looks like there is no scratch mark on the rock from the glass. If there was a scratch mark on the rock from the glass, then you would count this rock towards number of rocks that can be scratched by glass, and you would stop testing this rock. If glass does not scratch or leave a visible scratch mark on this rock, you are going to move on to the nail. It's kind of hard to see, but this did leave a scratch mark into this particular rock. If it does make a scratch mark, you are going to count this towards number of rocks that can be scratched by a nail, and you're done testing. If the nail does not leave a scratch mark, then this is going to be counted towards number of rocks harder than a nail. Okay. The reason we do this is we are building up an order of hardness, so if it can be scratched by your fingernail, it is very soft. And then if a single nail cannot scratch it, it is the hardest it has. This is using the Mohs hardness scale. Now, we are not testing it all the way up as we do not have access to all of the materials to do so, but these 4 simple tests will give us a general idea of the hardness of the rocks found at our site. Once you are done testing one of the rocks, put it to the side, take the next rock out of your the sample and run the same tests again. Once you're done with all the rocks from one of the sites, put the rocks back and begin testing the next sites.